In this video, we're going to take a look at the graphs of circular functions. And I just want to preface this with saying, this is a video that's going to warrant watching a couple times and some definite pausing. This is the first time we're really challenging you to look at this style of a graph in your math journey. So it's something new and different. And just like anything that's new and different, it's going to take a little bit of adjustment to get used to. When we look at the graph of sine and cosine, they're what we call periodic functions. Periodic functions are functions that cycle through a repeated process. Ideally, if we have a good heartbeat, our heartbeat is cycling through a repeated process, and in each cycle, the distance between the spikes is the same. Again, if we're healthy, when we go into duress or when our heart is not healthy, then we don't have this nice periodic function. Some other things that are periodic would be weather, tides, and hours of daylight, because we're cycling through if we look at multiple days back to back to back. Periodic functions are functions such that every real number in the domain, so x values are our domain, and sum of the positive real numbers p. The least possible positive value of p is the period of the function. This is kind of some really technical math. We're going to actually take a look at what this means in the real equation, and it's going to make more sense than this slide does. In a periodic function, we have things like this unit circle. So the circle with a radius of 1. The circumference of that would be 2 pi r. The radius of our unit circle is 1, so it would be 2 full units. This means that the least possible value for our 2 pi r would be 2 pi, which means the period for sine and cosine is 2 pi. So that's being derived from the unit circle. So therefore, if sine and cosine functions are periodic functions with a period of 2 pi, and apparently PowerPoint is like my pi, the following statements are true. Sine x is equal to x plus any multiple of 2 pi. That's all that means. It would be x plus any multiple of 2 pi. So 2 pi, 4 pi, 6 pi, any of those values. Those are all going to be periodic functions with a period of 2 pi. As the value increases between 0 and pi over 2, my x values, so I know it says s, but it really means x values, sine goes from 0 to 1. Let's think about that with the unit circle. If I have the unit circle, that's quadrant 1. So look at the sine of 0 and the sine of 90 degrees. The sine of 0 is 0. The sine of 90 is 1. Everything in between is going up towards 1. So it should make sense as we plug in values when we're graphing sine x between 0 and 90 that our function is going to go from 0 to 1. So it's going to be headed up towards the y value of 1. Cosine of 0 is 1. Cosine of 90 is 0. So it should make sense that cosine does the opposite, and it goes down between 0 and 90. Now, when we're graphing, we always graph in radian mode, so I'm using the degrees here to give you an explanation, but you do need to utilize the radian. So what does this look like? Well, this is my sine function. Notice between 0 and pi over 2, it's going up. Between pi over 2 and pi, look at your unit circle. Between pi over 2 and pi, if you follow those angles, they go down to 0. Between pi and 3 pi over 2, they keep going down in the unit circle. And then they cycle back up between 3 pi over 2 and 2 pi. So again, this is the y value or the output of sine. And if you find the sine of these 4 values, you're going to find that behavior. I took the liberty of putting all of the sine values here. So if we look between 0 and pi over 2, it cycles through closer and closer to 1. Then I have these other values where I didn't put the full cycle, but you can see the full cycle here. If you are in radian mode, this is going to be the nice pretty graph your calculator is going to give you. If you're in degree mode, you're going to get something that looks crazy. It's not going to look like that. So if you have a problem, it's probably not in the right mode. The domain of sine is negative infinity to infinity because I can plug in any angle. However, the range will be from -1 to 1 because I can't get a value out larger than 1 from just sine x. I would have to do some kind of modification. So the graph is continuous because it has a domain of negative infinity to infinity. The x-intercepts are in the form of n pi. Look at my x-intercepts, 2 pi, or negative 2 pi, negative pi, pi, 2 pi. Those are going to be my intercepts. The period is 2 pi unless I change it. And the graph is going to be symmetric with respect to the origin, so it's an odd function. This might be something you might have to memorize if you're not really good at visualizing even and odd functions. Cosine, it's still going to have that continuous domain. It's still going to have the same range. As we talked about it, between 0 and 90, it goes down to 0. And then it goes down to negative 1 at pi, back up, and continues up till it arrives back at 1. So cosine has very similar functions, except our x-intercepts aren't multiples of pi. They're going to be those fractional multiples of pi over 2. And 3 pi over 2. So it's not quite as pretty. This is going to be symmetric about the y-axis, so it's even. Again, if you're not great at visualizing that, you might want to just write it down. I can start altering these graphs by starting to put things in front of them or inside the parentheses. Any value in front of a trig function is going to change the amplitude, meaning how high or low the graph goes. So for y equals 2 sine x, I'm multiplying every output by 2. So sine of 0 is 0, that's still true. The sine of pi over 2 is 1, but now it's 2. 0 and 0, it was negative 1, now it's negative 2. So essentially, all you're doing is taking the standard graph of sine and moving the mountains and valleys down to negative 2 or up to positive 2. That's changing the amplitude. The amplitude is actually the measurement of half the distance between the maximum and the minimum value. So this is 2, this is negative 2. The total distance between these two is 4. So if I divide that to get half, my amplitude is 2. It's also the number in front of the sine. So it's not like I'm asking you to graph paper and measure it. You can definitely use the number in front of sine to find it. So the value of A is my amplitude, but I always use a positive expression for it. Even if there was a negative 2 in front, I wouldn't say negative 2. I would say my amplitude is 2. It also affects the range because it's affecting how high or how low the trig function goes. So this case, now I'm taking the amplitude and I'm doing something inside the function, so 2x. So I'm doubling all of those angles. So pi over 4 becomes 2 times 45, which is 90. 3 pi over 4 becomes 2 times that, and so on. Pi over 2 becomes 2 times pi over 2, which is pi. So it's shifting what's happening with my cycle. So I'm basically affecting the cycle of it. One complete cycle is going to happen much quicker than it did when I didn't have the 2. So here is how we're going to address that. We're going to say that the period of a function is 2 pi over b. 2 pi over b is going to be my period. So if I'm looking at this function, b is going to always be the number in front of x. So if I have 2 pi over 2, my period is now pi, not 2 pi. In this example, I would have 2 pi over 4, which would become pi over 2 for my period. So when we're using the period, we're using this function with the number in front of x, not in front of the function, the number in front of x. So if I want to graph y equals sine of 2x and compare it to sine x, I can definitely use Desmos. That's absolutely okay. Or I can know that the amplitude is 1. The period is going to be pi because it's 2 pi over 2. And that's going to occur over 1 period, 0 to pi. I'm starting to look at these endpoints. And basically what you're going to do is take those endpoints of 0, pi over 2, and you're going to divide them by 2. That's where these values are coming from, as I'm taking all of the traditional values for sine, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi, and I'm dividing them by 2. to get these endpoints. So now it's going to follow the same cycle of up and down, but it's going to do it at the new coordinates, not the old ones in red. So if I have a period and it's 2 pi over b, and the same thing would be true with cosine 2 pi over b. And that's going to basically shrink or expand that nice pretty cycle that the curve goes through. So if I want to graph cosine of 2/3, I'm going to figure out 2 pi over b, which is going to be 3 pi. My endpoints are now 0 and 3 pi, and the other endpoints are going to be 3 pi over 4, 3 pi over 2, 9 pi over 4. Well, let's look at where that's coming from here. I've got my traditional cosine curve. Let me find the cosine curve for you guys. Give me just a second. I have my traditional cosine curve, and I'm taking all of these points and I'm affecting them by that period change of 2/3. So I'm dividing everybody by 2/3. And that's going to generate this graph. Notice the cycle is the same. It goes up, down, back up. But the cycle that it goes through is much quicker. So here are some guidelines you can use to do it. Step 1 is to find the period. That's always the first step. Step 2 would be to divide the interval into 4 equal parts. So you can take the interval from 0 to your period and divide that into 4 equal parts, or you can look at those traditional points and shift them. Then you're going to plug in and evaluate for each one of those values. You're going to plot the points. You're going to connect the dots. So this is kind of like when we did parabolas. You knew your x-intercepts and you would find your vertex and you would connect the dots. You should have the shape of sine and cosine memorized in your head so that once you have your 5 points, you can correctly connect the dots. So here's when we're putting it all together. We're going to graph -2 sine 3x. So b is 3, telling me my period is 2 pi over 3, which gives me the endpoints 0, 2 pi over 3. Then I'm going to divide this into 4 equal parts to get my 5 coordinates. Once I have my 5 coordinates, I'm going to plug them in. Now, these 2 steps don't need to be done. The 3x and the sine of 3x, that doesn't need to be done. You can just plug directly into this bottom row. I think we're all mature enough to do that. Once you do that, that gives you your points. You plot your points, and then you connect the dots. So if you're following your steps, it's really going to be helpful. When A is negative, it doesn't affect the amplitude, but it reverses the graph. So let's look at what that looks like. If I have -3 cosine pi x, that's a pi, over 1 period, my period is 2 pi divided by pi, which is 2. I love when this happens because our 4 endpoints are so much easier to find. So I find my endpoints, I evaluate the curve. Now, the cool thing about this way is if you're using these steps and not steps found on YouTube or a different provider, when you connect the dots, it's going to be easier. You're going to plot your 5 points. When you plot your 5 points, it should be immediately apparent to you that this is not going to go up, down. This is going to go from the bottom to the top. The key of knowing this is that my amplitude was my amplitude is 3, but it was -3 in front of the function. So it is basically flipped upside down. And if you're following those steps, it's going to be so much easier for you. Now, you can definitely graph this in Desmos. Here is a caveat to that. The lab is going to start asking you, what are the x-intercepts? That can be a little bit difficult in Desmos because it doesn't always tell you in terms of pi. It's going to ask you, what is the period? What is the amplitude? So the end goal in the lab is not always going to be having a graph that's generated. Sometimes the end goal is just going to be having those points or those calculations done. When b is an integer multiple of pi, it's really nice because we're going to have x-intercepts that are rational numbers. So if I'm looking at this graph and I want to determine an equation from the graph, the first thing I'm going to do is look at the amplitude. Well, I'm going from -2 to 2. So that tells me that a is 2. And I started below the axis, so that's going to tell me that my a is -2. Then I'm going to start looking at these coordinates, and my period is 4 pi. So if I know my period is 4 pi, then I'm going to do 4 pi equals 2 pi over b. I'm going to solve for b, and I'm going to get 1/2. Well, now I'm done. I know if it was -2, because it goes from -2 to +2, it starts below the axis. And then I know that from my period, meaning it completes a full cycle at 4 pi, I'm going to set up that period equation and solve for it. So those are times that the Desmos is not really going to be helpful to you in completing your homework within the lab because you're still going to have to puzzle through this. So don't think that we can do this all in Desmos because we're still going to have to use those critical thinking skills.